Hi, this is Victor Morganti from Fact Engine. I'd like to discuss some of the important issues that will likely arise when developing databases and front ends for databases when ISO-GQL becomes more prevalent within the industry. And a lot of that has to do with the interplay between property graph schema traditionally of graph databases and entity relationship diagrams, their meta schemas in general, and a concept which I'm going to call a relationship node or an edge type node type. So where there is a choice that can be made, especially over a relational database, but also a choice that is made with graph databases, so traditional graph databases, as to whether or not a particular relationship is presented to the end user of the schema or the database or the front end property graph schema viewer as either a relationship, so an edge type, or a node type. Now we're looking at a schema, property graph schema here in front of us over the top of a database, and it is over a relational database, so it's over a SQLite database for demonstration purposes, but it could also be Oracle or Postgres or SQL Server. It could also be MongoDB or practically any database, because as we move towards ISO-GQL, we'll merge towards the concept where any database can be viewed as a multi-model database. And if we forgive and put aside for a second various nesting possibilities with JSON type, document type databases, but which can also be presented with object role modeling if ISO-GQL moves towards object role modeling as being central to the provision of a meta schema or meta schema for ISO-GQL in its implementation within various databases. But what we're going to focus on in the first instance is this concept of a relationship node or a edge type node type combination, and let's have a look at this schema right here. So what we're looking at is a schema for a cinema where a person can make bookings for a seat, to go to a session to watch a film. So we have cinema at the top here. We have sessions, so a session is like a 10:30 session to watch a film at a cinema, and the session is for a film, so we might go and see Grease or Rocky or Dr. Zhivago or something like that. And where a person makes a booking, so a booking is for a person and a booking is for a session, and where our database has a typical likes relationship, so where a person can like a film with a rating, and where the booking is for one or more seats. Now I'll get back to this, but a seat is in a row, and a row is in a cinema, and a seat is in a section like Gala or Public or Deluxe section or something like that. So depending on how big the seats are, and how much room you've got for your popcorn and drinks and things like that. So this particular node type here, booking has seat, makes sense. So booking has seat relationship, or booking seat relationship expressed as a node where it relates to a booking, so it's for a booking, and it's for a seat, so these could be is for labels on there. They've inherited has because this same node type here can be expressed as a edge type. So booking has seat and a seat has a booking. Now we're looking at the Boston conceptual modeling and database management software that sits over the top of databases, and it uses a double arrow for a many-to-many relationship, reflecting that the relationship is reciprocal. And if I click on that, I should see that. So booking is for a seat and a seat has a booking, but it's a typical has relationship. Now, depending on how the ISO-GQL is implemented in full, this may revert to a single arrow, and I think there's room for debate on how that works. But let's just say ISO-GQL reverts to a single arrow. You might have booking has seat, and then you can, of course, always in GQL or OpenCipher or Cipher do a reverse predicate in your match clauses and things like that to get the relationship between booking and seat. So that particular edge type, we had a choice. We could have a choice as to whether or not that is a edge type or as a node type. Now, what is particularly interesting about that is that in this relational database, if I should be able to just morph directly to a entity relationship diagram, and that becomes a many-to-many table. So it's a many-to-many relationship, but also a table at the same time, and that's what gives us our many-to-many relationships. So if I go back to our property graph schema, that becomes this particular node type. If I change that to an edge type, go back to the ERD and morph to the property graph schema, that should just disappear as a edge type there. So we had a choice. Now, you mightn't picture it seeing this particular property graph, but session and booking are exactly the same. In Boston, you can't revert this to an edge type because it's got extra edge types joined to it, so it becomes a node type by default. But if a person booked a session, that's an edge type. So if I'm lucky, I've got a if I go to the ERD, perhaps I might have a graph label. Let's open the object role modeling view. So if I go to booking and I have a look at its graph label, I can add a booked relationship there. So a person booked a session, and it's more visible within object role modeling. You can see there's a fact type there which has been objectified to become a table or a node type. And if we see session up here, where a session is a combination of film, date, time and a cinema, we're saying a person booked a session. But it's the same for session, where we can have a graph label on session and where you can say is showing at. So film is showing at cinema, and we totally ignore this value type here because it's not pertinent to the relationship when it comes to a property graph schema view, when we treat the database as if it were a graph database. So a film is showing at a cinema. Now if I close that and we go back here, so even though this is a node type, and in this particular software you can't express this as an edge type, there is an edge type relationship there, and I believe that the ISO-GQL people will need to make a decision as to whether or not to allow queries that match film is at cinema and simply pass straight through session rather than a long-winded GQL query where we have to say session is for film and session is at cinema, etc., etc., to be able to get our results. And so too for a booking where we can say, match a person, booked a session, and talk about that where that session is at. So in that case, you would use session as a node type. You would say, match a person, booked a session, with your ASCII arrows is at a cinema, and nominate the cinema. So that's the concept of what I call a relationship node, and most visible where there aren't multiple edge types joined to it, as in this booking and seat, where we can say we can display that as a node type, and now we have it as a node type and we have a choice. Now if we look at the relational view, as in a traditional, say, database management tool, we have a table, booking has seat, and with the columns, there's multiple columns there. Now I would argue that it's never going to be the case that all relational databases are simply going to drop a multi-part, multi-column primary key in the same way that Neo4j Enterprise allows you to have particular properties which are mandatory for a relationship, for an edge type. And so in Neo4j Enterprise you can definitely say that all of these particular properties are mandatory for a particular edge type. So if I click on that edge type, person ID, film ID, date, time, and cinema ID in Neo4j Enterprise can be said to be mandatory for the relationship between booking has seat and booking, if you so wanted, and that's what you pay a premium for in Neo4j Enterprise. Now these three here relate to seat, so the row number, the cinema ID, and the letter identify the seat. So the row that it's in, the cinema ID, and its letter, so A, B, C, D, etc. So I would argue that in a relational database, I mean, if people are selling ISO-GQL to relational database type people, I believe that, say, a organization as PostgreSQL may not subscribe to the notion of simply having single column unique IDs and dispensing with all these other very useful bits of information where we can get information about a booking simply by the date, time, the cinema, and the row number, say, and the letter, and we can find information very quickly without having to do a whole series of joins to be able to get that information. So if we've got these columns, they're there for our use, and we have a booking has seat table with multiple columns. If I look at the graph schema view, and this is a graph schema view of the same schema, we have our various node types, so booking has seat. These are off screen at the moment, so adult, child, cinema, film, person likes film, row, seat, section, and session. If we look at session, and we know that session has a film ID, a date, time, and a cinema ID, there we are. So cinema ID, date, time, and film ID for that particular node type. Now once again, I would argue that ISO-GQL over a relational database isn't likely to dispense with columns per se, and multi-column primary keys. So these hashes denote a primary key, and so the primary key is across film ID, date, time, and cinema ID, and we've got those 3 columns there. Now, session is an entity or a table in our relationship view, but within this particular software, we're acknowledging the concept of a edge type node type combination, or what I call a relationship node. So if I look at session, it's also down here as film is showing at cinema, and I should be able to query on that. So film is showing at cinema, and it's got the same properties: cinema ID, date, time, and film ID. Now I'll show you how actually doing that sort of query in a moment, but there's something I want to clear up first about the metamodel of an entity relationship diagram and a property graph schema. So there's some debate that the metamodel of a entity relationship diagram is not the same as a property graph schema. Now, I'll say this up front: you can program and develop meta schemas which are, or meta models which are different. However, fundamentally, these two particular diagrams have the same meta model, and it's provable. So now, if we talk about an isomorphism or a homomorphism, there's a 99.999% homomorphism between the meta model of a entity relationship diagram and a property graph schema. So if I take this particular entity relationship diagram and I view its meta model, so that's going to open up as the meta model now in a 4-layer architecture. So if I just zip over here for a second, so the meta model, we're using object role modeling as a meta model and a meta model. We're looking at the meta model now of a entity relationship diagram, and that's here. We can see the particular data that is behind this meta model in order to get a drawing up on the screen. And if I view the fact table there, no, I should be able to see this one. If I view the fact table, I'll see a whole lot of data behind this particular relationship. There's none showing here because it's at the model level, and I can suck it up to the page level and vastly increase the speed of loading models and stuff like that, but that's particular to this software. And basically we're saying that a person is an entity, a row is an entity, a person likes film is an entity, etc. So that's the entities that we're seeing on this screen. Now, the only difference in the interpretation of this meta model and its data is a single column down here, or what transpires to a column. So if I show its fact type name and just drag this over, that's a Boolean flag on an entity which says whether or not it's a property graph schema relation or not. So whether or not it's one of these things. So whether it's a relation, so an edge type, or whether it's shown as a node type. Otherwise, this is exactly the same meta model that you would use for a property graph schema, and I'll prove that. So if I click on this page, I have the language of the page. So at the moment it's an object role model. Now if I change that to a property graph schema, so this page now is a property graph schema, and I go back to my model explorer and it was this entity relationship diagram ERD main. And if I go to ERD main, it opens, clicks over to that object role model. So I'll do that again just for show. So if I click on ERD main, it is this meter schema with its data. But if I double click on it, what should happen is that it should, or edit, no, maybe I have to close it first. If I close it, and I won't save the changes, but I'll edit it, it's now a property graph schema, and I can get it pretty much looking exactly the same as our other one that we were just looking at. So it isn't that you can't have a simplistic meter model that's different from an entity relationship diagram. The question is, why would you? And I'll explain why. So if we've got this property graph schema with exactly the same meter model as its corresponding entity relationship diagram, and if in our meter model, let's say cinema bookings, and if I go over to the XML that is that particular model, and you know, it's quite a, it's a couple of megabytes, something like that. So that's the meter model with all its meter models in it, and models and data. You could ask, why would you have two different meter models for an entity relationship diagram and a property graph schema when you can get away with one? And the reason why you might use one is because you might take person, and hopefully nothing falls over in a heap here. If I change person to customer and change that there, so that's changed in the entity relationship diagram, but by sheer virtue of changing it in the entity relationship diagram, that should have changed in my property graph schema at the same time. Which brings up another issue around managing meter models, is that it's one thing to have a theoretical 4-layer architecture. It's another thing altogether to be able to manage multiple different meter models. So I've also got a state transition diagram meter model in this same meter model, where we say a film is either pre-screening, screening, or no longer screening, and that relates to its object role model here, where we've got film screening status of pre-screening, screening, and no longer screening. And we've also got a use case diagram where we're saying a customer makes a booking where they call the cinema, select a seat, they select a session to watch, say, Grease, and then they select a seat, and then they confirm a booking, etc. And notice how customer has changed here within this. This would have been person before I changed it, and so too, we don't see it in the state transition diagram, but certainly in this object role model, person has changed to customer. So I'm going to argue that it is nigh impossible to manage so many different meter models without having an assembly of software similar to the software you're looking here, which is purely dedicated to managing multiple meter models and flicking over changes to the model, to the various meter models, as events are triggered, such as the change of an object type name or an entity type name from person to customer. And that it's more easily done when both the property graph schema and the entity relationship diagram have exactly the same meter model, which I've closed now. So if I open it again, there it is. There's the meter model. So if we're using exactly the same Metamodel, we can save ourselves a lot of grief, at least I believe so, by not having to manage multiple Metamodels, and where in terms of a homomorphism and an isomorphism we've got a 99% isomorphism, or homomorphism approaching an isomorphism, with only one difference being the this particular flag here, which says whether or not something is a, where's my property graph schema, I've closed it now, whether something is a an edge type, so film is showing at cinema, or whether or not it appears, at least appears, as a node type, so session. Now that's a decision for the ISO-GQL people to think about, but also it's something very much for database developers, and where tools such as Boston operate over the top of relational databases in particular, where it's very easy to treat a many-to-many table as either a edge type or a node type. Now this session table is by default a many-to-many table, so a cinema can show many films, and a film can be showing many cinemas, but the unique key includes date, time, and that's how we get our unique sessions there. But nonetheless, it is a many-to-many table, or an edge type, so film is showing at cinema at the same time as it is a node type or an entity or a table. So let's have a look at that in practice, and if I go back to the Model Explorer, go to this cinema bookings model and open up, say, Fact Engine. Now what we're going to do is we're going to demonstrate that in practice. So if I say which film, and hit the I key there, I should say is showing at cinema, which cinema. So which film is showing at which cinema, and hit go on that. I get Rocky is showing at the Great Western Cinema, Grease is showing at the Great Western Cinema, Dr. Zhivago is showing at the Great Western Cinema. Now Fact Engine is database agnostic, so we know this is a relational database because it's got this SQL-Lite flag against it, but this could be Neo4j. Now if it was Neo4j and we were using OpenCipher or GQL, what we would expect is that if I hit the go key on that, and touch wood everything works, that didn't work. Okay, just give me 1 sec, I'll fix that. So I've decided not to fix that, but actually just show you the query that it generated. It's generated from which film is showing at which cinema. The query match film is showing at cinema, return the film name and the cinema name, and limiting 100, and then that gets converted into SQL via a transpiler and run to get the query. If I have a look at that, so that's film cinema ID, if I have a look at the actual query and just fix that manually in this instance, where's film cinema ID? Okay, found it. So if I just change that to cinema, so I just got to do a bit more work on the transpiler here, and if I select that, take it back over to this query section, dump it in there, change that to SQL, run it. Okay, that needed to be film ID, and we should be able to run that and get our results. Okay, so I just need to fix the transpiler there, but we get the picture. So these results are the result of a GQL type query, so OpenCipher, that if I run the query, it'll convert it to say GQL or OpenCipher or Cipher, and translate that into SQL, and my results aren't there anymore. So that particular edge type does exist within a database, and it exists as this particular fact type here. So film is showing on date time at cinema, which appears as a table here, and where we could equally say which session is to watch the film, say Grease, where that session is at the Great Western Cinema, if we treated it as a is this going to open as a property graph schema, if we treated it as a node type. So that's a choice, and you know, it's kind of like, I mean it's not, but kind of like an axiom of choice in first order logic, where you know, you literally have a choice as to whether or not in a relational database whether to treat a many-to-many table as if it were a node type or an edge type. Now, I believe it's going to be hard to make hard and fast rules over that, because it really is up to the user whether or not they want to treat something as if it were a node type or an edge type. So this particular node type can become an edge type. Now, depending on how the user wants to treat it, will influence. Have I still got Fact Engine open? Will influence whether or not we have a simple query like this: film is showing at cinema, or we have to do multiple joins across a session node type. Now, I would argue that there is no automated way, that's disappeared there, no automated way to determine whether or not, let me reopen that, whether or not we have an edge type or a node type without making decisions for the customer for them, which may or may not upset the customer. So I believe it's an issue that the ISO-GQL team need to resolve and to discuss, and at least with Fact Engine we'll be providing choice as to what the customer wants to do when we generate a layer that sits over the top of a database. And so if I look at bookings here, just to prove we're over a database, I should be able to, nope. Let's have a look at cinema. Look at the data inside the database. So we're looking at, you know, the Great Western Cinema, Northern Star Cinema, Watson Cinema, Rialto, etc. And there's our data. So ISO-GQL in implementation could very well become simply a layer that sits over the top of databases, rather than being intrinsically at the very core of a database. And we could be looking at a stock standard Oracle database, or SQL Server database, or a Postgres database, or a MongoDB database, and doing these exact same queries over the top using a translation layer, and if the ISO-GQL team go towards this multi-model layer, multi-layer Metamodel to be able to implement the standard, and certainly in a reasonably rapid way, over a variety of databases, and bringing the beauty of graph database queries to an otherwise relational or even document world. So thank you very much for watching. I hope that shared some useful information, and I'll speak with you all soon. Thank you.